That was a great introduction. Hi, everybody. My name is Eric Vargas. You guys will see just mentioning two names here. It's just California Resources Corporation. As the introduction, I work for California TerraVault, that is a subsidiary of California Resources Corporation. California CTV, how I call it, the California TerraVault, is called CTV, has grown from really a conceptual phase a couple years ago from 5 people to now a couple weeks ago we got together, and I think I can count probably like 70 people, right? So it's been a huge undertake for us. So getting ready for this presentation, I was just thinking on the best way to open up the conversation, right? As part of the introduction here, we're looking on carbon solutions as a way to help the energy transition. Why? Because we believe in CTV, a carbon TerraVault, there is still a big gap between what has to be done right now and the future technologies that will help us achieve through decarbonization. So getting ready here, I went to the Copilot chatbot, Microsoft AI, and I say, hey, can you build a cloud of words on what is the most used words for the decarbonization, climate change? And this is what it gave me, right? It shows carbon as the most used word: gas, emissions, energy, renewables, zero, greenhouse, But I was surprised that everybody knows that carbon is a big contributor to greenhouse gases, right? But I see renewables there, but I didn't see carbon storage. I didn't see, solutions that we can apply today to decarbonize existing processes. And why is that relevant? Well, this is on a slide that I prepared for our board members. It talks about the California net zero goals, and this is something that's called the SB 100. The SB 100 is the Senate Bill 100. It was put together a couple years back. But it basically laid down the ground of how California intend to achieve the decarbonization goals by 2045. In summary, they say, hey, we want to get net zero by 2045, and we plan to electrify, all these sectors. We want to get, all the transportation that contributes 41% of the greenhouse gases. We want to get the 24% on industrial, and we want to then, put a dent on all the other processes, right? So what does that mean? It means that the state of California, in 2021, that this was published, they say, we want everybody to go to an EV car. We want everybody to drive an electrical vehicle because we want to electrify the transportation. So what is that translating in actual demand? When you start looking into the specifics of what is required to make this plan, they put together these scenarios. They put in a scenario in which you have still a component of hydrocarbons on it, and a component that has no combustion, no hydrocarbons on it. But I want you to see the scale on the left side. So this is megawatts, right? Or if you want to just remove 3 zeros, it would be gigawatts. California energy grid right now is around 85 gigawatts. That's the maximum capacity on the grid. That is, you can change that. That's what it is. You can try to put more, solar, whatever you want to do, but the capacity of the grid is what it is. It's 85 gigawatts. You cannot change that, right? But under this program, the government is saying, hey, we need to put, around by 2045 to achieve net zero, we need to go 3 times that, we need to go and get 3 times the size in resources to achieve net zero. And that's basically in both scenarios, well, in the scenario, sorry, decarbonization, in this one is around twice. So looking at about 2 to 3 times what is the grid, depending on the scenario you're looking at. But when you start looking into the granular part of this, they say, well, we want to depend a lot of renewables. They say, utility scale solar. We want to depend on solar projects. But here's the problem. Energy storage. So they're talking about bringing online a significant amount of energy storage, more specifically, long duration energy storage. And what is that challenging? Because there is no technology today that can deliver this amount of power on the amount of hours that they need it, or to make, in other words, a reliable grid. And that's removing really the problem of just increasing the size of the electrical grid by 2 or 3 times. This is another problem on top of the problem, right? So what I tell you this, because California is probably one of the states that has the most aggressive decarbonization goals. But when they put scenarios like that, they're depending on technology that is not ready, it's not commercial. Technology that under the DOE will be TRL 9. And we are probably right now developing long duration storage that is probably TRL 6 on the DOE scale. Then that's questionable, right? It's something that you have to question, is this really the right path? What we have seen recently, in the specific case of California, they're actually backing out. They say, look, we put this out, we now recognize we probably make a mistake. And they're talking now, even to you have Gavin Newsom recently talking to CARB, that is the agency regulating the emissions in California, and say, look, now we need to include carbon sequestration and storage as part of the plan going forward. And that is because when you start looking into, carbon storage, we have a way to take existing emissions from processes that are out there, let's say a power plant, and capture those emissions after the exhaust from the flue gas, or from the gas actually coming out of this power plant, transport this into a sequestration site, and inject those in the subsurface for a permanent storage that will last hundreds of years. In that way, we can use existing processes, existing facilities that doesn't require new permits, doesn't require new land disturbance, doesn't require using more land that could, jeopardize species, etc., into a carbon-free project, right? And that is really the thesis in which Carbon TerraVault is being built. We are a company looking to take CO2 from existing sources, mainly, and take those in the subsurface. In this slide, I'm showing you kind of the general concepts associated to carbon capture, right? Carbon capture is not new. It's something that has done, and we have developed for many years. There is natural deposits of CO2. I see some people drinking sodas. So some of that CO2 is actually coming most likely from a natural deposit CO2, right? Or it's coming from industrial processes that capture the CO2 and they put it in your soda. So we're not new to the CO2, to deal with CO2 or using CO2. We just knew on the way that we tried to tackle we want to use our expertise or our knowledge on CO2 to tackle climate change. Oil and gas companies have been using CO2 to enhance the oil recovery. So that brings that you have now a full industry. They have knowledge of how to use CO2 in the subsurface. I get this question all the time, and it's one of the questions is, are you guys doing this to extend the life of oil and gas asset, or are you doing this to use more hydrocarbons? And the answer is no. We actually, in CTV, where even we are a subsidiary of an oil and gas company, we're completely independent and we operate independently from the oil and gas company. Our goal really is to use the expertise that we have developed in the oil and gas. But if we want to monetize and we want to make a business out of the CO2 that we put at the ground, we cannot produce a single barrel of oil or hydrocarbons from the ground. The moment that we do that, we lose absolutely everything that we have gained in CTV, and particularly in monetization. And I'll explain it even more, in the further slides. We're looking to, develop like storing the CO2 deep in the ground. I mean, looking more at, the 6,000 feet. I think you want to hear about 26R. 26R is the first reservoir in California that has been repurposed for permanently storing, CO2. That's a depleted oil and gas reservoir that we're using. That reservoir is anywhere around, I would say, 6,000 in the shallow side and around 8,000 in the deep side. So we're looking here to significant depths to put the CO2. I will provide this context. I don't want to go in the details of everything. I think most people here, if you're here, you're pretty much interested in the topic. You realize all the nuances, all the details associated on carbon sequestration. But I think you take the general idea of capturing CO2 from the industrial process, transporting that into the injection well, injecting this into a reservoir that will have a cap rock and is not going to leak to the surface. That is anywhere between 6,000 or more on the ground. So why we started doing this in California? I think the simple answer is we're before CTV, when in the inception of this concept, we did this analysis to start looking, okay, what is the actual potential of California to develop, CO2 storage? So our assessment indicated that we have 1 billion metric tons capacity of storage. And the circles in this slide right here, they show the points in where you have emissions. So all those circles right here, that emission points. And for those who are not familiar with California, I'll explain you a little bit of this. So this is the Bay Area and all the industrial complex, all the refineries around the Bay Area. Here in the south, you have also all the ports associated to Long Beach, right? So you have a big cluster there. And then right here in the center, you have some refinery and other type of industry around Bakersfield, right? So our business model right now has, even that I started initially with just thinking on taking emissions or taking emission sources from existing processes, we find out there was the transportation component was a big problem. And when I say it was a big problem, or still a big problem, is because, the California have one of the most aggressive goals for decarbonization. However, does not have any type of regulation on CO2 pipelines. That means that whenever you want to put a new pipeline from an emitter that is outside your industrial complex to inside the industrial complex where you have the sequestration, there is no regulatory pathway you can get that pipeline permit, right? So here's when we start getting a little bit, I don't want to say the word political, but we start getting a little bit political, right? California has the most aggressive goals to decarbonization. However, the regulation doesn't support the decarbonization in the industry, okay? So because of that, we've been forced to looking into a slightly different business model. So now to co-locate the processes with the sequestration to avoid the transportation. We do think that the transportation, and we try to engage, we constantly engage in the governor's office and in Sacramento, and we feel now that we had good traction. We feel that the pipelines will be fixed. I mean, that situation of pipelines will be fixed. We're going to have definitely the pathway to do pipelines for CO2 in California. They want to enable now to move, emissions from longer distance, from, maybe from processes that are not necessarily co-located. So right now, in the meantime, we're resolving the situation of the pipelines. We're looking at developing co-location, sequestration with existing processes. Our first project in 26R, that is around the Bakersfield area, that is this point right here, is basically that. We're building an industrial park. Inside in that industrial park, we have a power plant that we own. And as an industrial developer now we need to, that we try to attract new processes to build on our site, we have to provide utilities. We have to provide water, electricity, and all those different things. But it does not make any sense if we try to decarbonize processes that we provide electricity that is not clean, so carbon-free electricity. So now, as part of our process, we have now to dive fully into renewables, looking into geothermal development, looking into long-duration energy storage, solar as a means to enable, our projects. So on the capture piece, the way we have two main enablers or sources of capital here. One is LCFS, that is through the federal government to the IRS, 45Q, and LCFS, that is low carbon fuel standard, that is California based program. They enables or provide you credits. So all this CTV business is building the foundation of federal and state credits, not charging, consumers for the use of, for carbon-free electricity, or for if you get a biofuel or something from one of the processes that we have, we're not intend that to be translated into or adding, a carbon footprint to the consumer. So all this is coming from the federal government right now. It's not going to last forever. It's only 12 years. And then after that, we're expecting the voluntary carbon market is being developed. That right now is in infancy. For those who don't know what is the voluntary carbon market, it's basically if I want to, let's say Eric Vargas wants to go and offset the carbon footprint, I can go, Google, where I can purchase carbon credits. Those will be in the voluntary carbon market, and I can offset my emissions, by buying voluntary carbon credits. That market is in infancy right now. We definitely see there is a big big momentum behind to develop the voluntary carbon market. But right now, for the next decade or so, it's going to be the federal government. Okay? And storage, the last component here. We have vast expertise on CO2 management and subsurface management to enable these projects. We not necessarily looking right now only on, let me change the slide right here. So we're looking at different types of projects. The list that you have here is the permits that are required in order to enable the project. So we call it the Class 6 permits, but they are done by the EPA. Basically what it is the EPA will give you the permit to inject the CO2 in the subsurface. There is a lot of requirements that you need to comply. CTV is leading the Zone 9. You see Carbon TerraVault, 26R. You see all these are CTV, and you see Aera Energy is a company that we just recently merged with it that is about the size of California Resources. They also have a project, it's called Carbon Frontier. That project came to CTV after the merger. So we're leading on this area on the west with all the permits. But all those permits that represent a specific site. So we're looking right now, you can count here, you can cluster these first two, they're almost at the same location, 26R and A1, A2. But we have CTV2, CTV3, CTV4, CTV5, Carbon Frontier, and what is not showing here is we just, a couple weeks ago, we put CTV6. All those projects are going to be, or right now the vision is to be an industrial park, providing the utilities with the ability to sequester CO2 in the subsurface. All of them are slightly different in location and also on subsurface properties. The only ones that are oil and gas, though depleted oil and gas reservoirs, are 26R and A1, A2. Everything else in that list, all the way to Carbon Frontier, Carbon Frontier is also depleted oil and gas. CTV2, 3, 4, and 5, they're saline aquifers. And when I say saline aquifers is, we also developing the option to inject CO2 in saline aquifers and in other types of formations. We believe here in Nevada there will be right geological structures, and they have the right geology to also do the same. There is right now on 26Rs in A1, A2, there is no current production, oil and gas production. Those assets were seized by CTV 2 years ago. All the operations were shut in. All the wells are currently being abandoned because as part of the getting this Class 6 permit, you need to actually create a confinement. So if you have existing wells, that could be a vehicle that gas or CO2 can actually migrate to surface. So you have to abandon absolutely every well. And when I say abandon, you have to basically pump cement all the way from the reservoir to surface. So there is no way that you can actually use that well for anything else anymore. Then after that, you cut the surface, you dig around the well, you cut like a 10 feet on the ground, and then you cover it with dirt. And then after that, there will be an inspection, somebody come and say, you comply, and you are in conformance. So because of that, and I think one of the learnings, the early learnings as a CTV one to be almost a startup, is that we realized that going the oil and gas route, it was costing them more money because we actually have to abandon a lot of wells. And the cost of abandonment, once you start looking, at a significant number of wells, then the price tag started adding up. So now we're moving away from that business model and just looking at saline aquifers or other types of structures. So here's a different view of our projects. It's basically the same thing that I showed you before. You have CTV1. Under CTV1, we had 26R and A1A2. So in the previous slide, you saw A1A2 and 26R. CTV2, CTV3, CTV4, CTV5, Carbon Frontier, and as I mentioned, we just permit CTV6. Right now, here you can see in the central part of California, we have 202 million metric tons of CO2 permit, and in the north we have 145 million metric tons of CO2 permit. That is the capacity of the reservoirs. Here's the injection rates. We have the specific location. Injection rates are here. The estimated annual injection rate for each of the projects, and the potential total storage pipe project that is here at the bottom. All right, so we've been developing, we have all the permits now to have the storage reservoir or develop the storage reservoir. So what about the emissions? So right now we focus on, as I mentioned at the beginning of my conversation of this talk, we focus right now on greenfield emitters. And I say greenfield emitters, people that will come to our industrial site and build a new industrial process. That's what I mean. There is the brownfield emitters. That's really what we want to do. We really want to go and help California reduce their emissions by allowing us to decarbonize existing processes, right? But unfortunately, we cannot develop, storage everywhere. Storage depends on the geological conditions of the subsurface. So in order really to fix this problem, we need to be able to transport those emissions for brownfields into the sequestration site. So we right now put this option in pause right now, right? As you see here is direct pipeline, right? Is that what's really what depends here? On the new California greenfield emitters. So on 26R or CTV1, we typically make the mistake. We call it 26R, A1A2, but it's CTV1. CTV1 is the two reservoirs, the first side, the first industrial park. We have a power plant. We're going to have a pre-combustion capture and a post-combustion capture to reduce emissions. And we're going to have a bunch of new industries and new processes building in our site in the upcoming years. There is a really elegant way too to get those emissions, and this is through direct air capture. Direct air capture is a process that basically circulates air through gigantic filters that drive out a fan, and it's able to really take CO2 out of the air. What is that elegant solution? It's because when you start looking into decarbonize specific processes, and I was just talking previously with somebody about this, even sometimes going from one power plant to another power plant, you have to modify the capture component, basically how you actually going to take the emissions out of, how you're going to take the CO2 out of those emissions, right? Even sometimes they're built by the same company, but the process is so different that it requires a new engineering solution. So direct air capture, it actually helps us to remove those barriers. It actually, for systems or processes that are really difficult to decarbonize, this could be an easy solution. The problem with direct air capture, I'm going to tell you, is not everything is green in the green industry. The problem with direct air capture is it takes a lot of power and it takes a lot of heat, right? These are processes that demand massive amount of power. And at CTV, we think that the best way to implement the record capture is following the model of a company called Climeworks. We actually partnered with Climeworks, the leader on the record capture. And that's a company who actually, this inception in Iceland, and they have a record capture unit attached to a geothermal system, you know. So when you think about it, say these units require a lot of power. With the geothermal resource that you have here in Nevada, you know, to me it's no-brainer, right? You can actually bring the record capture to Nevada, you know, develop the geothermal resource and be able to offset remotely emissions, right? If you find the right geology to sequester. I feel really excited because I have tremendous conversations today with some people. They have ideas of where we can find those geology, the right geology for putting CO2 in the ground. So we at CTV, we have an eye in Nevada. We think this is an eventual area for us to expand. And we see at the record capture with geothermal, you know, the means to tackle the market here in Nevada. All the material is going to be provided. I just don't want to get into my slides. I realize there is a lot of detail on that. I will provide this all, you know, a lot of these slides are public in our investor relationship website, but I want to provide a copy here so you guys can have access to the material. So, respected to CTV1 and the projects that we have right now signed, this is the list. I mentioned we have a bunch of projects. So here are the projects. We have, this is a post-combustion capture. This is called CalCapture. This is from the power plant. We have the pre-combustion capture. This is also the power plant. We have Granules, that is a clean ammonia. We have Inintech. There is a RDME facility. We have Lone Cypress, this clean hydrogen. NLC, the renewable natural gas. Verde, there is renewable gasoline. Yosemite is renewable green hydrogen. And we have also a record capture unit that we plan to put in our first CTV. That last project of the record capture is, by the way, is sponsored by the DOE. We won in the last round for the DAC hub, we won a TA2. We now gearing up to go to TA3, that is basically the construction. The TA2 is mostly the pre-fee component of the record capture. We intend to have 2 units running around this site. One is going to be, and this is, I can say this because this is public. One is going to be Climeworks. The other one is going to be with Apnos. Both are leading companies on the record capture. So combined, we have, this is the projected CO2 emissions that we're going to capture from these processes, right? So we're going to have the sequestration on site. We're going to have the clean power coming from the power plant, and we're going to feed that power and utilities to those processes to really guarantee they are carbon neutral or carbon negative. Some of them will be carbon negative. So this is a slide on talking more about, you know, why California and how California is actually helping develop these projects on the financial side. So we have federal 45Q, we have California LCFS, we have California cap and trade program potential. That's with something that we're working. And we see California develop, spearheading the voluntary carbon market. Why is that important? Because if you hear me before, I say the 45Q or the tax credits are going to be good for 12 years. Then after that, we need to find another way to monetize carbon, right? I mean, the systems and all the projects that we have here, you need to be able to monetize the sequestration of carbon. So 45Q will enable, start right now, but after that we need a voluntary carbon market, a mature voluntary carbon market. I hear before somebody was asking, like, do you see governments putting a carbon tax, to everybody? I don't know. I don't think so. I think they may be in the future embedded in some of the goods and services that we get, but right now I really don't know. And I get this question quite often. Right now I think our taxes are helping with the 45Q or advance this. Looking here at the clock, so 43. This is Carbon TerraVault and Brookfield. One thing is, in addition to all the incentives and the support that we get in at the federal and state level, we have also at Brookfield, one of the global transition funds also investing in CTV. They own right now 49%. CTV owns the 51% of. So you have, what I would like to use or show this to people is, you see the capital markets, they're now looking at these projects. They want to invest. They see this technology to be something that is going to enable the energy transition, right? By providing, solutions now versus solutions in the future. There's a little more explanation on where we at with Brookfield and more in detail. All of this is public information. You see some numbers there, but don't be concerned. Everything is being, in an investor relationships website, so it means it's public. All right. I think this is around CTV. I'm going to just skip that, and I'm just going to go straight to the questions. Thank you.